Hi. Lesson 4.3 is about right triangle trigonometry, and I call this the flash review. So this is the trigonometry that you learn in geometry and algebra 2. If you'll recall, if we're looking at the triangle from the viewpoint of one particular angle, and we label the sides of the triangle based on that, this side is opposite the angle at A. This leg is adjacent to the angle at A, next to. This side, AB, is the hypotenuse, right across from the right angle. The six trig functions for right triangles can be defined using those words, opposite, adjacent, and hypotenuse. This way, the sine is opposite or hypotenuse, and the cosecant would be the reciprocal of that, hypotenuse over opposite. Cosine, adjacent over hypotenuse, and secant, the hypotenuse over adjacent. The tangent is opposite over adjacent, and the reciprocal function cotangent would be adjacent over opposite. I'm sure that many of you learned those trig ratios by following the mnemonic SOHCAHTOA. Sine, opposite hypotenuse; cosine, adjacent hypotenuse; tangent, opposite adjacent. Other teachers use this acronym. Oscar had a hairy old aunt. The sine is O and H. The cosine is A and H. The tangent is O and A. I always thought Oscar had a hairy old armpit would make more sense, but anyway. Let's apply. If AC is 12, so we have 12 here, and BC is 5, it says we should be able to find each of the trig ratios for, you guys, we can't do that unless we know how long the hypotenuse is, but this is a right triangle. So the hypotenuse squared has to equal 12 squared plus 5 squared. That's 144 and 25. Some of you are already there because this is one of the Pythagorean triples that you might remember. 144 and 125 is 169, and that's the square of the hypotenuse, but we don't need it squared, we just need it. So the hypotenuse is the square root of 169, which is 13. And many of you will have remembered that whole 5, 12, 13 ratio. All right, in those terms then, the sine, which would be the sine of angle A, would take the opposite leg over the hypotenuse. That's going to be 5/13 here. That means the cosecant will be the reciprocal of that, 13 over 5. The cosine for angle A would be 12/13. And the secant will be the reciprocal of that, 13/12. Tangent, opposite over adjacent, so 5/12. And cotangent, the reciprocal of that, 12/5. So what we did there, use the Pythagorean theorem to find the missing piece, and then write all 6 ratios based on SOHCAHTOA. Good. Now we are going to show you one problem of each kind of trig problem. I may do this differently than what you've learned, but basically there are only 3 kinds of problems. Ones where the variable are on top, ones where the variable are on the bottom, and other problems where the variable is the angle. So I break them up that way, and I'm thinking that this is going to give me a variable on top problem. So here's the angle of question. That's the one we're interested in. Opposite that is x, and it's the hypotenuse that we have. So we must think to ourselves, if we're going to find a value for x here, the ratio we need is the one that does opposite and hypotenuse, and that's the sine ratio. So we're going to write a sine equation for our triangle. That is, the sine of 58 degrees has to equal the opposite side x over the hypotenuse, 24. And when the variable is on top, then to get x alone, we multiply. So our x is going to be 24 times the sine of 58. For me, I call this the multiply problem. Variable on top, we multiply. Let's get a value for that. Make sure that your calculator is in degree mode since you're entering an angle measure. So I just press the mode key, And oh, it's a good thing I checked. Mine was in radians, so I go down to that row. I want to highlight degree. Again, I need to do this because I'm entering an angle measure that's given in degrees. So now I can do my multiplication. 24 times the sine of 58 gives us roughly 20.4. It's about 20.4, and these were feet. That does make sense since the hypotenuse is supposed to be the longest side. The second type of problem has a variable on the bottom. So I'm looking at this thinking, okay, 72 is the angle that I'm interested in right here. X is the hypotenuse, and 5 is adjacent. And that means we're talking cosine. So the cosine of that 72-degree angle will equal the adjacent 5 divided by the opposite x. The algebra to get x by itself has to go this way. You can't have it in the bottom of a fraction, so you multiply both sides by x. X's here cancel. And then to get x by itself, we got to divide by the cosine of 72. Divide by the cosine of 72. Bottom line is x will equal 5 divided by the cosine of 72. And folks, I call this the divide problem because the bottom line is that you divide the number by the trig thing. Okay? Calculator, tell me, 5 divided by the cosine of 72 is approximately 16.2. 16.2 inches. So we've had two types of the possible three. We've got variable on top where we multiply, variable on the bottom where we divide, number by trig daily, and the last of the types are variable in the angle. So I'm looking at this. D is the angle I'm interested in. I have the side opposite and I have the side adjacent. That's tangent. So the tangent of x degrees is equal to 70 over 25. Folks, we need x, we don't need the tangent of it. So our x is going to be the tangent inverse. This is where you use the inverse tangent function. X will be the tangent inverse of 70 over 25. And I'm going to go to my calculator and ask it to do that for me. Second and tan, and I need 70 divided by 25. To the nearest tenth of a degree, that's 70.3. So we've looked at the three types of triangle problem. Now, solving a right triangle means find everything that's missing. Find all the missing parts. And in this one, we're missing an angle at M, we're missing the side N, and we're missing the side M. So let's go for the easy one first, the measure of angle M. Well, that's going to be 90 because this is a right triangle, so 90 degrees are already gone. 90 minus 65. And that is 25 degrees. So the measure of angle M is 25 degrees. That's the easy part. The rest of it's not too bad either. I'm going to put that 25 here because there may be some advantage to me in using that angle instead of this one at some point. Actually, it's happening right now. If I want to find the side M, which is opposite of the 25, and I have the side adjacent, I could say the tangent of the angle M, 25, is equal to M over 16. I like the multiply problem better, so I am always appreciative when I can do that. Tangent 25 times 16. Please don't forget, if your calculator opens a parenthesis for the tangent function, you must close it. If you don't close it, you'll get an answer, but it will not be the right answer. Tangent 25 times 16, that's about 7.5. About 7.5, and these are centimeters. All right, I have two routes I can go. I now know two sides in a right triangle. I could use the Pythagorean theorem, or I could use trigonometry, and I always am going to want to use trigonometry. So I'm going to go with the angle O that they gave me at 65. 16 is opposite that, and I need the hypotenuse. Opposite and hypotenuse are sine. The sine of 65 degrees will equal 16 over n. To me, variables on the bottom, this is a divide problem, so I'm going to say my n will equal, it's the number divided by the trig dealy, 16 divided by the sine of 65. 16 divided by the sine of 65 is about 17.7, roughly 17.7, and those are centimeters. Does that answer make sense? I think so, because we were finding the hypotenuse. That's got to be the longest of the three sides. So we solved the right triangle. All right, found all the missing pieces using trig. I love it. Wouldn't be math if we didn't have an application problem. So I have a picture here of Devil's Tower, which is in Wyoming, and it's just a huge rock formation. It says that the tower is 1,280 feet above the valley floor, so I'm going to draw a simplified picture. 1,280 is the height of that. We're asked about shadows in this problem. If the shadow of the tower is, and I'm not drawing to scale, but if it is 2,100, we want to find the angle of elevation of the sun. That would be the angle that if you're on the ground here, you look up to see. Angle of elevation, you look up. So we're looking for that angle right there. And I'm going to think to myself, that I have opposite and adjacent. So the tangent of my angle will equal 1,280 over 2,100, and I know that x, the angle, will be the tangent inverse of 1,280 over 2,100. Okay, tan inverse, so second tangent, and it is 1,280 divided by 2,100. That is roughly 31.4 degrees. Good. The next question, B, asks us to use the same thing. How long is the shadow when the angle of elevation is 38? So now we know different stuff about it. One thing is true. The height of the rock formation is not changed. We want the shadow when the angle is 38 degrees. So opposite and adjacent, this is another tangent problem. The tangent of 38 will equal 1,280 over x. Variables on the bottom, that's a divide problem. So x will equal the number 1,280 divided by the trig dealy, tan 38. 1,280 divided by the tangent of 38 degrees, 1,638 feet, about 1,638 feet. Would be the length of the shadow. All right, one more problem. If a person at the top of Devil's Tower, so now we're at the top, so we are 1,280 feet up, sees a hiker at an angle of depression. Oh, here we got to just remind you, the angle of depression is the angle that he looks down to see the hiker, but it's also, since this top is ground is parallel to the line of sight, it's this angle too. He sees a hiker at an angle of depression of 65 degrees. Those are alternate interior angles. Now we're really asking you to think geometry. Between parallel lines, they have to be equal. Angle of depression from the top is the same as the angle of elevation from the bottom. How far is the hiker from the base? So this is the distance we want. We've got a new angle, 65 degrees, opposite and adjacent still, so this is still a tangent problem. The tangent of 65 degrees will equal, opposite is 1280, adjacent we don't know, but variables on the bottom, so I know I'm going to divide. X will equal 1280 divided by the tangent of 65. So 1280 divided by the tangent of 65 degrees is going to give us about 597 feet. About 597 feet. Very good. That's our flash review of trigonometry. Get out there, do the U-try, and I'll see you in class tomorrow.